So, without further ado, I'd like to hand it over to our keynote speaker this morning. Jeff McVeigh is a 17-year veteran of Intel, and oh, I need to read his title. He has an incredibly long title here. Jeff is the General Manager of Performance Client and Visual Computing within Intel's Developer Products Division. And he's actually also a doctor. He went to Carnegie Mellon University, and I hope nobody at MIT took that against him while he's been here in Boston. But without further ado, I'd like to hand it over to Jeff.
Thank you, thank you. Yeah, I had a chance to run over to MIT yesterday, and I didn't wear my CMU attire, so I'm still safe. So thanks a lot for showing up today. It's great to be here. I am from Oregon, so I really appreciate the later start to the keynote. It's much appreciated. I'm going to talk about going native today, and I'll get into what that is. But first, let me describe a little bit of a personal story or something that happened to me recently that kind of sets the stage and gives me perspective on what it means to develop for Android. As I mentioned, I'm from Oregon. I'm not talking about this type of native today, but I am going to tell you a little bit about an Oregon-related story. This is Mount Hood, the big volcano that you can see from Portland, Oregon. It's about 11,000 feet in height. Great place to go skiing, mountaineering, hiking, whatever you want. It's a fantastic winter, summer destination. I'm an avid skier. I love to do downhill skiing. I'm also a runner, so I figured there was a race coming up that's called an alpine touring or randonnée race, which is basically you climb up the mountain on your skis and then you race down. I figured I'd never done it before. It's a sport that I'd like to get into, so I might as well jump in and give it a go. So I went out, got my equipment. It's mainly downhill-oriented equipment, but I did some modifications so I could travel uphill, put skins on the bottom of the skis. The race field was about 60 people. I was looking across and I said, maybe I might be able to place here. I feel like I'm pretty fit. I can do a good job at it. I was sorely mistaken. The gun went off. Even though somebody was dressed up in a Pope outfit, they're racing way ahead of me, charging up the mountain, and I'm huffing and puffing and breathing. I'm trying to figure out, what did I learn here from my experience? One, we all climb the same distance. It's about 2,000 feet up. My equipment, though, was way not appropriate for the event. Mine was over 20 pounds. Talked to the person that won. His was less than 10. This is my first race. The person that won was a repeat winner. I am embarrassed slightly to say that the person was over 60 years old that won. And they beat me by about 25 minutes or 26 minutes. So besides being a little humbled and put back in my place here, it let me kind of come away with some critical lessons. One, never underestimate the competition. Even though I looked across the field when I started and I thought I could actually do pretty well in this race, I didn't really realize the experience, the talent, and the abilities of my competition. The other one, though, is I could have started out this kind of experiment in a new field for me, this alpine touring racing, by trying it on my own, doing a smaller event, or trying just practicing more myself. Actually, I found it very valuable to jump into the deep end of the pool immediately. It allowed me to see how the best, at least in the Portland area, does at this type of thing. It allowed me to learn quickly, see how they tune their process, how they develop what the skills are necessary to win. Also, is optimizing for the right bottlenecks. I was optimizing for the downhill portion. My skis were well tuned for that, not best with all the weight for going uphill. That's really where you spend most of your time, going uphill, obviously. And then choosing the equipment or my tools wisely was a big mistake of mine. I can't claim that if I had the best equipment, I would have won, but I know it didn't help me. So these things are lessons that I would like to apply to Android development specifically. When Android first came out, as I watched it evolve, we sort of had this view of Dalvik would be the solution for everywhere. It allows for cross-architecture execution of applications, and that was the expectation from my standpoint, was that the Dalvik VM would be the main development vehicle for people developing their applications. While it still is, if we look at the top 2,000 applications within the Google Play Store today, only 1/3 of them are using Dalvik only, or pure Dalvik. The other 2/3 have some level of NDK, some level of optimized code that's compiled to a specific architecture or a fat binary. The question we need to ask ourselves is why? Why are people spending more time on NDK development? And my feeling, or my belief, is it's numbers like this. As of last week, at least, there was 1.2 million applications in the App Store. How does one become maybe not the #1 application, but the top 100, the top 1,000, even the top 10,000, is set yourself apart from the competition. That trend in applications has increased about 50% since last year, and I don't see it stopping at all. But it's important for us as application developers to realize, how do you rise above that noise? What do you need to do differently to make your application stand out? And I believe part of it is really taking full advantage of what the platform offers you in terms of its capabilities. And that's part of what NDK applications can do for you. The other one is, and I know this is an Android conference, but the world doesn't stop there. What I'm showing here is installed base across different operating systems. Obviously, Android has had an incredible rise in its installed base. 2010, less than 100,000 to over 1.6 million devices, active devices in the field. This is not per sales per year, but active devices in the field. Mac OS and iOS devices continue to rise as well, not quite to the same level. And then Windows devices, your PCs and other devices that run Windows operating systems, they obviously had a big head start. Those devices often aren't turned over as quickly as phones and tablets might be. So as a developer, to really reach the broad base, I can't just focus on Android. I need to be looking across platforms, across operating systems, and developing my collateral, my presence, my applications to span that experience. My personal experience is I've got my MacBook Air, I've got a Windows desktop, iPad, Android phone. My daughters all use iPhones. I'm sure everybody has very similar experiences at home in their lives, and you need to be able to have that same experience span across them. So multi-platform, multi-OS is a critical element to help you stand apart from your applications. So the question is, it's really time to make yourself stand out from that crowd. My sort of stylized view of the Boston Marathon earlier this year, the starting line, we've got hundreds, I think over 300,000 people ran it. How do you become somebody that stands out, that gets to the front of that field? 3 big things from my standpoint, and I'll go into more details here. Targeting multi-platform from the start. You can't think about this afterwards, after you become successful. Start there with that in mind. Architect your application to do that. Also, the devices themselves will continue to increase in their capabilities. Moore's law continues on. We will continue to drive incredible performance capabilities while living within the battery life required for mobile devices. And we need to expect that and develop applications that can scale up to the maximum that those devices do, not just going for the lowest common denominator. And then utilizing cross-platform tools to help you basically reduce the cost of your development, be more productive, bring your applications to market faster, and differentiate those. So let me get into some of the details for each of them. So the first one on architecting the solution. Now you can look at it from saying, I'm only going to be on Android, so let me do a Java-based application running on Dalvik. I've got all my code there. Maybe I intertwine a lot of my UI code with my logic of my application. Actually, I think we can do better than that. If we have a view that we've got some shared level of code that would span across these architectures, maybe you're reusing it from existing codes or libraries, written in some portable C++ code, and then for each architecture that you're running on, you've got either Objective-C, C#, Java, and having a clear separation between them so you can really reuse to the maximum extent that portable code underneath. I like this quote from Steven from the Dropbox team just last week at a conference when they looked at how did Dropbox design their cross-platform solution. They could have gone at it with a mindset of, we're going to have a separate team that does our Android application, a separate team that does our Windows, a separate one on iOS. And they said, well, let's have commonality for a major portion of the application. Allows them to do code reuse. They have common bugs between them, so they're not refixing them across different architectures. And the quote is I think, really telling here. They looked at it from a client-server architecture, looking at that portable, high-performance, sensitive code as really the server that has 0 latency and is never offline. But if you kind of have that separation, it allows you to generate cross-platform portability and OS portability much more effectively. The other one is on the use of tools. And I'm going to do a little bit of my plug here for some Intel tools that I think are highly valuable for this community here. One is the Intel XDK, which is an HTML5-based solution. I'll go into more details on that, as well as INDE, which stands for our Integrated Native Developer Experience, both cross-platform and cross-OS support for native application development. The XDK is, as I said, HTML5 focused. It utilizes Crosswalk, which is an HTML5 runtime to provide common solutions across browser technology. It's an entirely end-to-end IDE experience. You've got a brackets integrated editor. You've got debug, analysis, and deployment. And we launched this about 14 months ago, and it's had really strong pickup in the marketplace. I've seen some rankings. It's in either the top 2 or 3 HTML5-based solutions in the marketplace today. It's available now. One of the key things about this is, as part of it, it utilizes a cloud-based build packaging solution, so you can easily target across iOS, Android, Windows, ties in whatever your store of choice is, and allows you to package your application up and deploy those very effectively. So again, all within one integrated IDE experience. Switching gears to INDE, this is more focused, this is completely focused on people that are developing NDK applications, high-performance native C++ applications, for example. The main flow here is that you can take and develop within your favored host OS, Windows, OS 10, for example, and your favorite IDE, be it either Visual Studio, Android Studio, Eclipse. Go through it with consistent tools and libraries from creation to building, debugging, and tuning, supporting both Intel architecture and ARM, and deploy those then across multiple devices, across Windows, Android, and Mac-based platforms. It is beta form today. We launched the beta at MWC back in February. We are working through the beta process. We admit that it's not perfect. We'd love feedback on how to improve it, but I'm going to go into quite a bit of depth here in terms of what the capabilities are. Before I do that, though, let me just kind of re-emphasize one point, the support across architectures. The other sort of personal story is my daughter and I have been trying to do some basement renovation ourselves. We're not experts at this at all, so it's taking us months to get it done. But one thing that I've learned is, you need to have tools that are flexible. I've got a electric drill, and it would be a real pain if I had to buy a separate electric drill that supported Phillips head screws versus flathead screws. Instead, it's nice to be able to have one that I can flip the bit when I need to go between them. And that's the mindset that we went into developing INDE to support ARM as well as Intel architectures. Now, honestly, we know that we can't have the exact same support across them because we just don't have the same knowledge and interfaces to some of the metrics and capabilities that are on ARM-based platforms. But we really put ourselves in your seats as developers saying, if I'm going to commit to a set of tools, I need to have something that's going to support the breadth of architectures that's out there in the marketplace today. And that's really the mindset that we went into developing it. So some of the key features, we do support sort of easy setup for NDK applications. If people sat in any of the lightning talks yesterday, you saw how to add x86 targeting for your NDK apps. This sort of automates that process for you. We do support cross-platform and cross-OS performance libraries. We've got direct access to some of the key hardware, specifically on Intel platforms like video acceleration for 4K, HEVC codecs, imaging, graphics compute. It includes a C++ compiler supporting multiple target operating systems. It also embeds GCC if you're seamlessly use that for ARM and Android, and as well as OpenCL for offline compilation and runtime. On the debug side, we have a Visual Studio plugin using GDB that builds upon VS Android, graphics frame debugging supporting OpenGL ES and DirectX. And if you're familiar with Intel's Haxum, it's a hardware-accelerated emulation solution that allows you to do a lot of high-speed test out of your application on x86-based host systems. On the tuning side, we support both real-time metrics viewing, graphics frame analysis, as well as a timeline analysis. I'm going to do a real quick fly through these just to kind of give you a glimpse of it. You can learn tons more at our booth. We've got a whole setup that you can walk through this yourself, but let me just give you a quick flavor, and this will be a super fast fly through. So I mentioned you can easily support generation of new applications within within Android Studio. Simple few clicks builds that up. You can support targeting x86, ARM, MIPS, or a fat binary across them. Same thing within Visual Studio. A few clicks and away you go. You've got your Android NDK application there. You can choose what you want to target, and away you go. We also have a set of libraries to add unique visual computing or video processing capabilities into your applications. Simple things like screen capture and streaming. A few lines of code that I'm showing there allow you to do that. That interface to, after you've got some game logic, for example, you want to capture a frame either for storing the game, for streaming it, like a Twitch type of experience. That's supported with the libraries. A few lines of code also allow you to do video transcoding between formats, all utilizing hardware acceleration when possible on the platform, or falling back to a CPU software-only solutions if that's not available. We've got an Intel optimized C++ compiler that has over a decade of performance tuning that we've done on Windows platforms and Linux platforms that we brought now to Android as well. It seamlessly integrates into your IDE. It automatically selects based on the target. And it's also compatible with GCC. The main selling point here is that on this spec int benchmarks that we're showing, it's about 30% improvement in performance over GCC. Obviously, your mileage may vary based on your application, but you just get that native boost of performance basically for not really having to do anything. It automatically selects based on your target which one to use. We also support debugging within Visual Studio. Simultaneously supports both emulation and real device debugging over USB, supporting the full IA instruction set, including AVX and AVX 512. We've got some capabilities around debugging visual graphics frames, for example, an output of an OpenGLES frame buffer. And one quick story on this one, we kind of did a quick preview of this at GDC back in March to a few select partners. And I'll go without saying names, but a certain OSV came up and was impressed with it and was impressed that this actually supported ARM devices as well, plugged in their Nexus phone to the demo system and was easily able to find something wrong in their browser that they hadn't discovered previously. So this is an example of us bringing those capabilities cross-architecture for you as developers. We've got real-time metrics. Think of this as your EKG heart rate monitor, looking to see where things are between CPU and GPU bounds, so you can then dive deeper into analysis and tuning. Looking at hotspots, where in a timeline of your application, where are you spending most time between the CPU and GPU. And then also doing deeper level of analysis within the platform itself at the graphics frame level, where you can basically roll back some of the steps in your rendering process and figure out where the bottlenecks are in that. So with that, the sort of super fast walkthrough of what is INDE and XDK, those are really looking at our cross-platform tool suites to help, hopefully, your lives and your development. The next area is around really pushing the envelope of Android. As I mentioned, Moore's Law continues. We're going to continue to improve the performance of the underlying silicon and architecture. And there's some exciting new devices that are coming out based on Intel Core processors running Android. I won't kind of pre-announce anything that they're doing. But there's also this breadth of other devices that are out there. Just this week, I think 2 days ago, Toshiba announced a new line of tablet devices in the $100, $120 range supporting Android. We've got Samsung, Acer, Asus. The breadth is out there. Intel has a stated goal of shipping over 40 million Android or tablets this year, not just Android, but overall tablets. We beat our ramp of that in Q1 and are putting everything we can to make that possible throughout the rest of the year. So it's really critical as Android developers. You might think, Intel, why are you even here doing a keynote? One is really around our focus on understanding the developer's needs and delivering the tools necessary to be successful, and then also showing our commitment that we are in this game to play with respect to Android devices and tablets and phones. So be ready for that. We're here to help out wherever we can. In conclusion here, my key points are really on, by going native, it's important to you to really target this multi-platform solutions from the get-go. It increases your awareness, it increases your reach, it increases your focus and understanding within the community. Utilize the cross-platform tools that are available, both cross-OS and architecture, to reduce your costs and speed your time to market. And then finally, it's really important to scale your applications. Be looking out in the future, going where that hockey puck is going, as opposed to where it is today in terms of its capabilities. Don't look at the lowest common denominator platforms. Look out in the future. Really help yourself set your application apart by utilizing the full capabilities of that platform. You can learn more about what we're doing at these links. We also have our booth presence. We're giving away Dell Venue tablets that feature Intel Android. You need to download a little application and take some selfie photos of that for you. And you can contact us at these locations. The Code Native is my personal Twitter one. You can follow me there, as well as we have the other links here. For me, it's really important for us to kind of break free from that crowd. And I'll just put my last kind of plug for the Boston Marathon here. Be that person that can really break free from that 300,000 people. Don't be held back by focusing on that lowest common denominator, one architecture. Span across your architecture. Lean in, stand out, go native. Thank you.